Okay, this is TempleOS 5-minute random code walkthrough, episode 15. And I'm your host, Terry Davis. So let's see where God sends us. Alt-B. Looks like the compiler. Compiler backend 1C. Okay. Well, now let's see what we have. Assign. Okay. So when we do an assignment, if we say I64I equals 4, we say otrace traces the compiler. So there's an assignment immediate 4 to register variable RSI, and what it does is it loads an immediate into that register. The shortest way to do it is to clear the register, then put a 4 in the low byte. Okay, so that's what that one does. But anyway, so in this case we're using A, B, C, AX, BX, CX, and DX are free to trash between each intermediate code. So in this case we had an enter subroutine, and assign, a label, and a leave. Okay, so you're free to trash AX, BX, CX, and DX in between each code. So so what this is doing is it's the addressing modes of the x86 are somewhat limited. It's 1.5 operands. What that means is we have this many addressing mode types, and if it's a register, we can pretty much do it directly. But if it's not a register, we have to put it in RCX. We're moving an argument for an intermediate code is a triple type registered displacement. So this is one argument for the assign, and the other argument for the assign is right here. Here's the other argument, and so if it's not if it's a register variable, it uses this, and that's about that's one instruction. If it's not a register variable, we have to load the address of the location in CX, and then we do an assign indirect to CX with 0 displacement. So what we're doing is a move RCX, comma, and then this is one of the okay, so if it's moving to a register, we can do a move directly. But if it's moving to a location, then we load the location. The location might be a displacement off of a register. Maybe it might be in a structure. Let's see, we're not moving the address. Anyway, we do it a two-step process. We load into RCX, and then we load we set up RCX with the location, and then we do an indirect assignment. So the move instruction, displacement with 0 is indirect assignment. So this second move right here is a displacement with RCX, which is the and we're a zero. It's a with 0 displacement. So now this can be a perhaps we're doing a byte. Maybe we're sticking AL into a location. Anyway, if this can be a 64-bit, a 32-bit, 16-bit, or an 8-bit, and the way my type is a value that contains a raw type. So the type contains a raw type in the low 4 bits. So the raw type in the low 4 bits, and in the upper bits, you see how these are shifted over. The upper 4 bits is the type, and the low 4 bits is the raw type. It's a stupid name, but it's the size, and if it's signed. Anyway, so that's what that does. If it's not an address, okay, so if it's not an address, that means it's a register. And if it's a register, we just move the value directly into we move the source directly into the destination. If it's not an address, that means if it's a register. If it is an address, then we do this. Anyway, so how about that?